Welcome back to another Daishinfinity video. In this video, we're going to talk about something that is not some theorem that we want to prove. Today is a fun question. It states that 0.999999999 going forever, so a decimal place with nines, is equal to 1. And I would like to prove this to you guys by using a mathematical symbol and mathematical tools that will let us prove this kind of formula. So let's dive right in. Before we dive right in, we have to take in consideration that 0.99999 the whole time is equal to 0.9 and then this dash. In German we say Periode. I'm not really sure about the English name, but we can demonstrate this decimal place, this small number, as a sum of many decimal numbers. Now how can we use it? How can we do it? We can take this 9 and demonstrate it as 0.9 and add 0.09 and add another 0.009 and so on. So now we have a sum of many different decimal numbers, and we can write this down as fractions. We know that 0.9 is 9 over 10. We know that 0.09 is 9 over 100. And we know that 0.009 is 9 over 1000. And we know that 0.0009 is equal to 9 over 10,000. And so on. Now for every single number we have, we see that the zeros are always getting added to the 10, the 100, and the thousands. So what we can do is we can demonstrate it as an exponent. But before we do it, we can take the 9 out of the all of the fractions and say that it's 9 times 1 over 10 plus 9 times 1 over 100 plus 1 over 1000 and so on. Now 1 over 10 is the same thing as 1 over 10 to the first power. 1 over 100 is equal to 1 over 10 to the second power, and 1 over 1000 is equal to 1 over 10 to the third power. So we can write this down as 9 times 1 over 10 to the first power plus 1 over 10 to the second power plus 1 over 10 to the third power plus infinitely going. Now this reminds me of a geometric series, where the geometric series is the sum where k goes from 0 to infinity of x to the kth power, which is equal to 1 over 1 minus x when the absolute value of x is less than 1. Now if we let x equal to 1 over 10, then we know that 1 over 10 is definitely less than 1, and we know that the absolute value of 1 over 10 is also less than 1. And k, well, k starts from 1 to infinity, not from 0 to infinity. So we have to do something. We have to write it down as 9 times the sum as k goes from 1 to infinity of x to the k, so 1 over 10 to the k. Now how can we write this down as a sum from k going from 0 to infinity? Now we know that we can write sums as, let's say, when we have a sum of ak where k goes from 0 to some infinity, which is equal to k going from 0 to 0 of ak plus k going from 1 to infinity of ak. So we have 1 to infinity. So we want this one. Let's call this a variable j. So if we want to solve for j, we're just going to subtract this on both sides, and we get k going from 0 to infinity minus k going from 0 to 0. So we can write this down as follows. Just have to erase everything so that I can write it down as follows. It will be 9 times k going from 0 to infinity of 1 over 10 to the k minus k going from 0 to 0 of 1 over 10 to the k. Now, k going from 0 to 0, it just means plug in k 0. So if we plug in 1 over 10 to the 0 power, anything to the 0 power is equal to 1. So we can write it down as 9 times something minus 1. And since we know the geometric series of so the sum of x to the kth power is equal to 1 over 1 minus x, so we're just going to write it down as 1 over 1 minus 1 over 10. Now when we multiply both sides by 10 on the fractions, we will get, sorry I forgot this parenthesis, it will be 9 times 10 over 10 minus 1 minus 1. So this is equal to 9 times 10 over 9 minus 1. Now what this will equal is that the 9's will cancel out here. So we'll get 10 minus 9, and that is equal to 1. So we have just shown that 0.999 going forever is equal to 1. And that is the thing we wanted to have. So now you can understand why 0.9 going forever is equal to 1. I hope you really enjoyed this video. Please like and subscribe. If you have any questions, like and comment. And we'll see us in the next Daishinfinity video. See ya.